This is a straightforward question on forces, but it's not quite as straightforward as it initially appears. There's one subtle thing that you need to be aware of to make sure that you get it right. Easy way to make sure you get it right, if you draw a little sketch. So we've got force downwards mg, and then we've got this acceleration upwards of 1.4 meters per second squared. So the thrust force must counteract the weight and then provide the remaining force to give it the acceleration upwards. So the force upwards due to the thrust, I'll call Ft, and that must be bigger than the weight and give you this resultant force. We can work out what the weight is, we can work out what the resultant force is. We know the acceleration is 1.4, and from that we know that we can work out the resultant force because F equals ma. So the mass was 12,000 multiplied by A, and we get, I've already done that one, it's 16,800 newtons. So that's my resultant force. So the thrust force must be equal to this force plus weight. So it must be this much bigger than the weight. So the weight is mg, and that's 12,000 times 9.8. So 12,000 times 9.8 gives me 117,600 newtons. Add those two together and that gives me the thrust force. And that's the thrust force is 134,400 newtons. Let's see, what have we got? Yeah, we've got that answer. And maybe I've got slightly more sig fig.